Hello YouTube. So for today we are going to solve this question 2593 on LeetCode, which is find the score of an array after marking all elements. Sorry. Let's jump onto the problem statement. So we have given an array consisting of positive integer. The array name would be nums. And what do we have to do? We have to start with the score equals to 0, and we have to apply following operations. So what we can do, we have to take the smallest integer of the array that is not marked, and if there is a tie, choose the one with the smallest index, and then we have to add the value of the chosen integer to the score, and we have to mark the chosen element and its two adjacent element if they exist, and we have to repeat it until each and every element in the array are marked. So I'll just describe this. So let's say in this nums we have this minimum as 1 right now. Okay, and so we'll mark this as in the first operation, and after doing this we'll mark this 2 and 3 as well. Okay, so now these first three elements have been marked. Now apart from this blue elements, we have the minimum element as 2, the next minimum element. So we'll mark the adjacent. In the right side we have nothing, in the left side we have 5, so we will mark 5. So we'll take sum of 1, and then we'll take sum of 2, and in the end just 4 is remaining, so we'll take sum of 4. So we'll add it, and this score will give 7 as output. So this is the basic problem statement of this question. And if you talk about the constraint, so it takes 10 to the power 5 times basically. The nums of length could be somewhere around 10 to the power 5 times, and inside the array there could be 10 to the power 6. I mean, in the worst case, there could be, you could find 10 to the power 6 size of the elements. So for this, our brute force approach might not work. It will give time limit error, because our brute force would be somewhere around big of n square. Why? Because we have to traverse this array to find the minimum, and then we have to traverse it to mark. So that makes 2 operations. So okay, so I'll jump onto the solution and intuition part, and I'll show you only the optimized version of this solution, which is by using minimum heap. Yeah, let's see the intuition part first, and how to solve it. So this is related to the problem statement. This we have given, we have to choose the smallest integer, and for a tie we have to take the smaller index one. Okay, so now let's say we have this array given, and so for the first operation, as I've already discussed, we have to choose this one because it is the minimum, and then we have to take this and this as well. So we'll mark this, and in the score we'll consider 1. Now for the next part, we'll take this and we'll consider it in the score, and we'll mark this both the elements, and in the end we'll have just only 4, and we'll mark this as well. So that gives me an output of 7. This is the main intuition. Now we'll use minimum heap, and we'll use set. Why? Basically because we'll take minimum heap because it will automatically stores on the basis of value. So from the in the ascending order, it will store the value, and if the element is same, then it will select from a smaller index. So this should be a default, this will be a normal or default behavior of minimum heap, and which is also the question is asking about. So we'll use minimum heap, and we'll store in the form of pair. We'll take value and we'll take index in this minimum heap, and then we'll take one set for checking of the duplicacy. So this is going to be our approach. So we have given this, let's say we have given let's take a example here. Let's say we have given 2, 3, 3, 4, 5, and then 2. Let's say we have given this array. So we'll just push this array into this heap. So it will now and the values are going to be 2 with an index of 0 for the first element, 3 with the index of 1 for the second element, 3 with the index of 2 with the third element, and so on and so forth. Now this heap is not going to store in like this way, it will store like this way only. Okay, I'll just erase this. Yeah, so it would be 2, 0. So first of all, the minimum value is 2, and then the second minimum value, then the third minimum, fourth, and then so on. Okay, so this will store like this. So our heap is this only, this much only. This is going to be our heap, and let me erase each and every element in the set. Yeah, that yeah, so this is, let's say this is our set. Okay, and we'll name it as marked index for checking only. So we'll now iterate in the first heap element, which is 20. Now we'll see if this index is present in the heap. Right now it is not, so we'll include this element and its previous element, which is -1, and its next element, which is 1, and we'll in the score, let me remove this as well. In the score we'll just update what we'll update, we'll update 2, because 2 is the first element. So for second, now second is 2, 5. So this 5 index, it is not present, so we'll add 5. We'll add one previous one, which is 4, and we'll add one next index of this, and we'll remove this from heap as well. So now we'll consider this 2 as well. Okay, now 3, 1. Now since 1 is already present, if you can see here, 1 is already present in the set, so we'll not include this in our score. Okay, and yeah, and then we'll go on to the next element, which is 3, 2. So since 2 is not present, so we'll add 2, and we'll add this in our sum, and this makes 2, the previous element 1, but it is already present here. Then the next element, which would be 3, we'll add 3 as well. So for this 3, it is also present. For this 4, it is also present, so we'll not mark it. So now this is going to be our score, and the score is finally going to be 7, which is the final answer. Okay, so this is regarding this, and the time complexity would be going to be somewhere around big of NlogN, and the space complexity is big of n. Why NlogN? Because log n to access the element in the heap, and we have to do it n times. We have to perform the operation like push and pop operation n times. So it would be big of NlogN. And space, the heap is going to take big of n space, and set is going to be take big of n. So that total makes of big of n plus n, which is n only. So this is regarding the intuition and the approach part. Now we'll see how to implement it. Okay, now here's the code I've written. So first of all, we are going to create a minimum heap priority queue. How? So we are going to take a comma b, and if a is equals to b, a of 0 equals to b of 0, that means this is the case when elements are tie. So we'll just compare it by index. So this is index. So 0 is value, and 1 is index. Okay, and then we'll return. Otherwise, we'll return only for value. So it will return the value in the ascending order. And now we'll traverse from 1 to n. N is basically nums.length, and we'll push our nums value of nums and the index into our heap, and this will automatically stores it in the this form, which we have mentioned. Okay, now we'll create one set of marked index for tracking purpose, and we'll create a sum which is of long long type. Now we'll iterate in the minimum heap, and we'll take the first element from the minimum heap and its value and its index. Now if now we'll check if this is present in marked index, then we don't have to do anything. Otherwise, we have to add it in the sum. We have to add it in the set as well. What do we have to add? We have to add 3 values. First of all, index, then index -1, and then index +1. So it will automatically calculate the value of sum when it is not present in sum. Not present in marked index, and it will return the sum. So yeah, that is all regarding the solution part. I hope you understand this, and yeah, thank you, and make sure to like and subscribe. Bye bye.